a very brief thing of why would you want to test your code, and then we're going to start writing some tests. So, many people would say that untested code is broken code, and I would be one of those people. I took a great testing course from James Grinning where he made everybody stand up. I won't do that to you, don't worry. And say, I'm a programmer and I write bugs. And then he proceeded to say, okay, you're going to implement this simple function. Now we're going to write tests. And maybe 20% of us had it right the first time. It's very difficult to do this or to write reliable code that does exactly what you want it to do without having the appropriate tests. So sort of my condensed philosophy on code, comments, and testing would be the code is what your program is going to do. The comments tell whoever's reading that why your program does that. And then the tests are telling somebody how the program does this, or how to do it. So it is testing is really a form of documentation, I think. So what we're going to do today is work with an example library called Mediogram. How many of you in here know what a Mediogram is? Okay, it's about what I expected. So Mediograms are these time series plots of weather data that meteorologists, like Ryan, absolutely love. So you've got temperature, dew point, wind speed, wind direction, all of these atmospheric variables that you can measure on generally something like a 24-hour plot. And we get a summary of what's happened over the last day at a given station. So this library is going to download data and then produce these Mediograms. And that gives us a lot of interesting test opportunities. So we have to do things like string comparison for building URLs to go download data. We have to test that we are downloading data properly from a remote source. And how do you do that and not have your tests tightly coupled to somebody else's server not being down? Because that's no fun at all. Doing things like array and numerical comparisons, and then things like image testing in the end. So go ahead and switch over to your terminals and make sure that you are in the materials. So testing with Python for me. If you run an ls or a dir if you're on Windows, you should see a folder Mediogram, setup.py, environment.yaml. You're probably already there if you just created your environment. And we need to install this example library Mediogram, but we need to install it in a special way. We need to install it where it's editable. So as we change things in our library, it's going to run our changed code, not to install it as a snapshot. So we're going to pip install -e for editable, dot. And then we should see successfully installed Mediogram. Anybody having issues with that? Okay, got one issue, couple. Yeah. So I'm going to clear my screen so you can see what I typed. Pip install -e dot. Okay, so we're going to go ahead while a couple people are getting their pip installs sorted out. And I'm going to tell you about what's called the 4-phase test pattern. So there's a great book, XUnit Test Patterns. It's about this thick and it makes great bedtime reading. And one of the great things out of that is this 4-phase test pattern. So it's setup, exercise, verify, cleanup. And we're going to use that for all the tests that we write today. So setup is where we go ahead and make whatever conditions we need to test the functionality that we're going to. Exercise is where we go ahead and test the thing that we're wanting to make sure it works. Verify, we check that result against a known correct result. And cleanup, we go ahead and do anything we need to reset our environment. Not really so relevant in Python as it is in other things like C and C++ or Java frameworks. But that is the pattern that we're going to go through for every test, and it's something that I even like to put in the comments, as you'll see. This is the step, this is the verify step, this is the cleanup step. So how many of you have ever run PyTest before today? All right. So PyTest is going to look in our directory here. So if I'm I'm going to go into Mediogram. You don't have to follow me along with this. I'm just going to show you. So we have a tests directory here. And in there I have a file test_mediogram.py. So what pytest does is it looks for a file that has test_something.py or something_test.py. It's going to go into that file and it's going to run any functions whose function name begins with test or any methods that begin with test contained in a class that its name begins with test. So test is the key word here that pytest is going to be going in and looking for. There's a lot of documentation on the pytest doc page if you want to go in and customize that and tweak it because you need to name it something different for some reason and so on. So what I want everybody to do in the testing with Python directory that you all are in, we're just going to run the command pytest. So we just ran the test suite, which we have pre-populated with you for, pre-populated for you with 3 tests. So we see that we have 3 tests that passed in 1.15 seconds. So a not very large test suite, but it was very quick to run. We can see in the file test_mediogram.py 3 green dots, each of those representing one of the tests. If we had multiple test files, which is perfectly legal, we would see all of those files listed with the tests after them. This is using what would be called the Hollywood principle of don't call us, we'll call you. So this gives you very little output on things that were successful, but if something fails, we're going to get a more verbose output. And that's really what you want in a test framework. If everything worked, you don't need to see lots of output. You need to see output for things that failed. So go ahead and open up your favorite text editor. I'm going to use VS Code and make the font size a little bit larger for you. And I'm going to look in the test_mediogram.py file. Is that large enough font for those of you in the back to read it okay? Okay. So remember pytest, when we ran it, it looks for a file that starts or ends with _test or test underscore. So test_mediogram.py, it goes into this file and it starts looking for functions that begin with test, and it finds this one. So this is testing degrees Fahrenheit to degrees Celsius at freezing. So we know that 32 degrees Fahrenheit should be 0 degrees Celsius. So let's take a look at this test. The first phase, the 4 phase, was setup. So here I'm creating 2 variables, freezing degf and freezing degc. Then I exercise, so I'm calling my degf to degc function from the Mediogram library, and I'm storing its result. And then I'm verifying using an assert. So all tests need to have some form of an assert statement that's going to say this equality is true or this equality is false. Does what I got equal what I was expecting to get? That's, if you don't have an assert, you don't have a test. You're not actually checking anything. You're just running some code and at best doing a smoke test of did this code run and not completely blow up. And then the 4th phase of this pattern would be cleanup, which there's not any necessary for this because we all love Python. And it does lots of nice things for us. Yes?
Does it need to have an assert, or could we have such and such raise value error, raise other error?
So you need to be using an assert here, yes. So I'm going to go ahead and modify this test so we can see what a failing test looks like. So let's say that 32 degrees Fahrenheit should really be 10 degrees Celsius. We know that's wrong, but let's save that and run our test suite again. All right, so this is a little bit different looking on the output. We see that I have a red F instead of a green dot for the first test. And then now it's called us with all the details of what has failed. It says, this is the failing test. It failed here at this assert. 0 does not equal 10. So we have caught an error in our code. 1 failed, 2 passed. So we can go back, fix our code. And if we run pytest again, now we have 3 passed tests. I personally, when I'm writing tests, first, I write the test before I write any production code. That's more of a test-driven development philosophy. But so you write a test, that test should fail because you don't have any code that's going to make it pass yet. And then you write just as much code as you need to write to make that test pass. And then you go write the next test, and then you write the next test. So I go from this, the test suite is red, it's not working, to it's green. And then maybe after I get the test suite green, I go in and clean up some things. This is a pattern called red-green refactor. And it's a really nice way to do TDD on your system. So let's write our own test. So in this test-mediogram.py file, we have this comment instructor-led introductory examples. So I'm going to be typing in there. And we're going to do a really simple test that doesn't touch the Mediogram library yet, just so we can understand testing before we have to try to understand this little library that we got that we need to test as well. So we're going to test Python's title case function on strings. It's a pretty straightforward function to test, and it shows us a string comparison test. So def, remember we have to have test as the first part of our function name, so pytest will go and find it. This is a common mistake that I see made where you write your test and instead of starting it with test, it would just say something like title case, and then you would write your test and you run your test suite and you say, gee, I still have 3 tests that are running because it's not actually running this. So make sure you're running the tests too. So test title case. The first step of our 4-phase test pattern is setup. So my input string, this is a test string. My desired result would be this is a test string. So remember the title case function is going to make the first letter of every word in a string capitalized. So what comes after setup in our test pattern? Exercise. Exercise. So the actual result that we got is going to be our end string dot title. So we're testing the title method, the string method. Okay, and now we need to verify. So we want to make sure, we're using the assert keyword, that our actual result is equal to our desired result. The last step is cleanup, and there's none necessary. So let me give you a chance to get caught up typing that if you need to. Yes. So also remember if you need to get caught up, if you have to go take a break, which we're going to take several during this, don't worry. On the course webpage, right now we're in this testing basics section. There are some of the things I talked about, should look very familiar. And here's the test that we just wrote. So all of the things that I'm going to write are on the webpage in case you need to step out. So now I'm going to run pytest. And I have 4 tests that are passing. So that's exactly what I expect. We didn't do the red-green refactor since I'm not developing any new code here. So we didn't really follow that pattern. We're just testing a built-in string method. But now you have written your first test using pytest and run it, and hopefully it was successful. Maybe you had thought that title was going to be smart enough to not capitalize A, so that was your expected result. And if you run it, you would get a failing result, of course. So you say, well, I expect to get this out. I didn't go read the documentation on how this is going to work. You wrote a test, and this test just saved you because the function did not do, or the method did not do what you thought it was going to. It's helpful with using methods that other people have written. It's also really helpful for using methods that you wrote anything more than about 6 hours ago. Okay, so what we're going to do now is you're going to write some tests. These are going to be a little bit more complicated tests. You're going to call a function from Mediogram, and you're going to do a string comparison. And you might say, how do I know that this function in Mediogram is returning this correct string? You can either trust me, which is a very dangerous thing to do, and I don't recommend it, or you can try running it and follow this URL that it's going to build and say, is that a valid URL? So we're going to test a function in Mediogram called build ASOS request URL. So this is going to take a station name, a start date, and an end date. We've got a nice doc string there that helps you out. And it's going to build up a URL that we would need to go to get the data for that station at those times with this giant set of F strings here. And then return that to us. In test Mediogram, under this exercise 1 comment, we've got 2 tests for you to fill out. Notice the test names are really long, and that's okay. You should do that. You're never going to have to type these. PyTest is going to go find them and run them, other than when you create that function. And it's much more useful to have a very long descriptive test function name, so when it fails and you see that failure, in the red text in your terminal, you know what failed other than build ASOS request test 1 failed. That doesn't tell you anything. Build ASOS request URL single digit date times. That tells you exactly what happened. So we want to make sure that, say, with January 1st it works, or with double digit date times, November 11th. Does that still work? So you're going to write 2 tests here that have single and double digit start and end dates. Call that build ASOS request URL from Mediogram and do a string comparison test. So go ahead and start filling those in. Probably take about 15 minutes or so. So take your stickies down if they're up. Green ones up when you're done. Orange ones when you need help. Okay, so let's go ahead and go through how to do these solutions together. All right, so see lots of green, so that's great. So we're going to do the single digit date time. So the first phase is setup. I'm going to create a start time. In my case, I'm going to use January 5th at 1Z 2018. To January 9th at 1Z. Now, as one of you pointed out, and a couple people said, well, you didn't tell us about X, Y, or Z. And yes, because that's how real testing works. There are time bombs everywhere. So if you tried to request data from this month, this archive happens to update monthly. So if you requested data from like yesterday to today, you probably got nothing back. and that may have been confusing. So one of those things to play with. Generally, when I'm requesting data, or I'm building a URL to request data, I request something from a year or so before the current time, just to be sure that it's in whatever database I'm looking at. Station. We said FSD was a valid station identifier. The next step was exercise. So the result URL, I'm going to call mediogram.build ASOS request URL. Remember, tab completion is your friend when you're typing. And it takes the station, start, and end. After we exercise, we need to verify. So we've got a truth URL. And then we need to assert that the result URL is equal to the truth URL, cleanup, none. So a lot of folks said, how do I know what the truth URL is? And well, you don't. So if somebody had handed me this code and said, you need to test this, what I would do is exactly what we've done here. I would set truth URL to be an empty string, run the test suite, see what came out, and then I would go to that web address. So we'll do that. Is this a valid thing? Did it produce a URL that goes to the data that I'm expecting to get? We would need Wi-Fi to do this, yes. So I'm going to go ahead and run the test suite. Date time is not defined, all right. So we need to go up here and import date time. Okay, so we get this assertion error that says all of this stuff that it created is not equal to empty string, which is definitely true. So I'm going to copy the URL that our build URL function created. And we will paste it into the web browser. And there we go, we get data. So that is a valid URL. So yes, you could indeed trust that I built the URL correctly. It wasn't quite that mean when I made the test suite. So now we can say that is our truth URL. We trust that. Run pytest again. And it passes. So the same thing for the double-digit date times. In fact, you could copy this, and I'm going to, so you don't have to watch me type all of this again, since we are a little bit tight on time. But in general, copying and pasting things in tests is a really good way to accidentally run the same test twice, because you go in and forget to change this. So maybe I'm going to go from October 11 to October 16, and just for fun we'll make it at 11Z. So we're testing everything double digits now. So now if I run this test, it should fail, right? We still have our URL from the other one here. We run pytest. Yep, it definitely fails. So you always want to make sure that whatever you expect to fail really does. So I'm going to make it an empty string. Run it. Check my URL. Okay, that's valid. I got data. Put that in as truth. and make sure that we're passing. So what questions do you have about that exercise?
Couldn't you just copy from the main function the URL that has the whole formatting string?
Yeah, and you can modify that manually. You could go to the Iowa Mesonet webpage where this comes from and go through their little web form and click, okay, I want this date and this date at this station, submit, and see what URL it generates. There are several ways that you could verify that. That is one of the hard things in a lot of scientific code testing is what is truth. I mean, sometimes it's great if you have a paper, you're implementing a calculation, and you can say, this paper says the result of this calculation with these inputs is 42, and do I get 42? Yes or no? But we're rarely that fortunate.
Is it overkill to like use like request or URL or whatever to make sure that URL is actually true? Or is that too far?
Okay, so the question was, can we use requests or URLlib or something to actually try to go to this URL and see if it's valid? No, it's not overkill, and we're actually going to show you some ways to do that later on. Yeah. Okay, so that's strings, but we do a lot of things with numbers because a lot of us anyway do science. So in our test mediogram here between exercise 1 and 2, I'm going to show you real quickly how to do a numerical comparison, and you'll see it's really no different. So def, remember I'm creating a new test, so test is the first word in the function name. Does 3 equal 3? This is not a very interesting test. So I'm just going to call assert is 3 equal to 3. So the exact same pattern as what we did with strings will work with integers as well. So I'm going to run this, and then I'll go back to the code just to show you that now we have 5 tests that pass. So can anybody imagine how you could get into trouble doing something like this in real computational numerics work? Floating point numbers, everybody's favorite. So I'm going to write a test for floating subtraction. Alarm bells should be going off in your head right now. So setup. My desired result is going to be 0.293. Exercise. 1 minus 0.707. Verify. We're going to assert that actual is equal to desired. Cleanup. None. Oops. So go ahead and try to run that and see what happens. I'm sorry, I know this is a little low for those of you in the back, but I want to have the code up at the same time here. So when you run that test, we get a failure because 0.293, a bunch of zeros, 4, does not equal 0.293. So testing hard equalities on floats is very, very dangerous. And it will come back and haunt you at some point. Granted, this example was chosen to do this, but you will run into it. So what are some ways that we could get around that? Yeah.
I has a function called isClose that
So one step further, then yes, we're going to get to there. Yeah, so you could round it. What was that? Oh, so make it a integer by, okay.
Manually put in a tolerance.
So you can manually put in some kind of a tolerance. So let's do something like that. So I'm going to say, right. So actual minus desired. Take abs. Ah, thank you. And then is that less than some tolerance that we say we're okay as long as we're within 0.00001. So if I run my test suite now, it passes, yay. Having to do that every time you were doing a numerical test would be a gigantic pain and a lot of reproduced code, multiple places in your test suite. Again, that should be setting off alarm bells, and you should be getting the code smell off of your keyboard real bad if you keep typing that over and over again. So I'm actually going to use, so NumPy has a testing module. It has assert almost equal, as was mentioned. So up at the top of our test mediogram, I'm going to say from numpy.testing, import assert almost equal. You can look at the docstring for this if you so choose, but you can specify a tolerance. I believe the default tolerance is 6 places after the decimal, which is just fine for most things that I do. But if you wanted to specify, I only care about 3 places after the decimal, or I care about 12, you can specify that. So now we go back to our test. And we can get rid of this big mess and just replace it with assert almost equal, actual, and desired. If you wanted to specify, I only care about it to 2 places after the decimal, you can use this optional argument. Now if I run the tests, everything passes. It's clear what's happening there because it has a descriptive function name. Are these 2 things almost equal because we're doing things with floating point numbers? Okay, pop weather quiz. If I say the wind, we have a north wind, does that mean the wind is out of the north or to the north?
Out of the north.
It is out of the north. That will be important for your next exercise. So what you're going to do, if we go to the web page, we have the verbiage here as well for you. In this exercise 2 box, so you're going to add a function to the mediogram library to calculate the vector components u and v of the wind, given the wind speed and the wind direction. So if this is my wind vector, that's my u component, that's my v component of the wind. We've provided the formula there for you. So u and v right there, with theta being the wind direction. So what we want you to do is verify, write tests, write the function, and write the test to verify that you get the proper behavior at 0, 45, and 360 degree winds, and a wind speed of 0. You can do this trig, on a calculator, or if you really trust your coding, you could see what, just see what comes out and say that's the truth, but that's always dangerous. Or use some values that you can do in your head. Wind speeds of 1 and 45 degrees, some trig things should start coming back. So try writing that function and writing those tests. Sticky notes down until you have success or need us to come by and give you a hand. Okay, so let's look at how I would do this. And I was thinking going the other direction, from U and V to wind speed and wind direction. There you have some problems with 0 wind speed. What would the direction be? But in this case, we don't have any undefined behavior. We weren't quite that mean when we wrote this exercise, which we'll have to correct before the next time. Okay, so in mediogram.py, we're adding a function wind components. It has 2 arguments, the wind speed and the wind direction. Since we're being nice to ourselves and anybody else that has to use our code, we'll put a doc string here. Vector components from the speed and direction. And I would probably put a lot more in that doc string, like the formula and so on, but to save us some time and so you don't have to watch me type documentation, we won't do that here. And you could specify in there, do you expect the wind direction in radians or in degrees? I would expect to give this function wind direction in degrees, since I have never seen a weather report that, wind of pi over 2 radians today. So I'm going to go ahead and make my direction input radians. Then U is going to be minus speed times sine direction. V is minus speed times cosine of direction. Return UV. So any questions on implementing the basic wind components function in the library? Excellent. Okay. So now we have it. We need to write some tests. All right. Test wind components north. So my setup, speed of 10, direction of 0. Exercise is the next phase. U, V is mediogram dot wind components, speed, direction. Verify. So my true U is 0. My true V is minus 10. So if this is a 10 meter per second, mile per hour, we're not specifying wind from the north, then this V component is minus 10. The wind is blowing to the south. Then we use our assert almost equal because we are potentially going to have floating points. We have trig functions involved. So U and true U, assert almost equal, V and true V. So now if I run that, I have 7 passing tests. A couple people asked, do each of these tests need to be a separate function, or can I put all of it in one? The best testing practice would be to have them each as a separate function. So if you just had one large test wind components and it had multiple exercise verify blocks in it, it's going to be harder to track down which one of those failed when one of them does fail. And when one of them fails, none of the rest of those are going to run in that test function. So you don't know if the others work or not. With them each being separate tests, each of them will run. It's a little bit more modular. Yes, we can clean it up, and we're going to after we take a break, because there's going to be a lot of repeated code here with 4 of these identical blocks. But generally, small compact tests that test only one thing, and you never have exercise, verify, and then do something else. After your asserts, the test is done, except for your cleanup. So follow that 4-phase testing pattern rigorously. Okay, so I'm going to copy this. And I'm just going to do one more test. I know you had to do 4. So let's do northeast. So speed of 10, direction of 45. True U would be negative 7.0710. And true V is the same thing. Our asserts are fine. And we have one that has failed. So the problem is 1, 2, 3, 4, 5 in the 5th place. We have a 6, and I did not specify that here. So I could go back here and say I only care about this out to 4 decimal places. Because if you're measuring the wind speed to more than 4 decimal places, you're kidding yourself. Okay, there we go. So that's a good example of using that optional argument when you're doing floating point comparison. Okay, so what things did you encounter here?
I was just wondering, is there just a way to parameterize unit tests so that you don't have to make 4 functions for different variables?
There absolutely is, and we will hopefully get to parameterization today, yes.
When you're dealing with less, like, known off the top of your head numbers, what's kind of the nomenclature for, like if I did, for instead of 7.0, like if I did 5 times square root of 2, like, is that acceptable kind of to do in the practice for the unit test? Or should I try to write out by hand the entire floating point?
Okay, so the question is it okay if I had something in here, I'm going to put a comment here, would it be okay to have 5 times MP square root 2 or something? That's what you're asking. Or would I type out? I would type out the floating point because you are now not only testing your code, but you're also testing square root from NumPy. I don't think that's a very high risk thing, but I would personally hard code the test results in. I don't like depending on anything else to generate my test results except my code. Other questions? Okay, so there's a lot of testing philosophy and things that we'll go over. And we will also look at doing some array comparisons and trying to clean this up a little bit right after the break. But I would encourage everybody to get up, go outside, get some coffee, stretch your legs. We'll come back at 10 past the hour on the dot. Thanks.
Yeah. I'm kind of stuck.
Okay, so let's start regrouping here. And we'll get to some more advanced topics later, things like parameterization, which was mentioned, and fixturing. But I wanted to show you another common comparison we might want to do is an array. Is this array equal to some other array? And we could use that to condense these 4 tests that we just wrote into one in a rather naive way, but a way that would work. Right? It might not be the easiest to figure out which thing broke because we're going to have to count through our array elements. But with 4, that's not too bad. I can do that on one hand, so I can handle that, I think. So we are going to write a new test. So I'm in test-mediogram.py. Just remember, test is the first thing. Wind components. So setup. This time my speed is going to be an array. In this case, 10, 10, 10, and 0. My direction is also going to be an array. 0, 45, 360, and say 45. So these are those 4 tests that we just wrote. 10 meters per second, knots, whatever, 10 units at 0, 10 units at 45, 10 units at 360, and 0 units at direction 45. Then we exercise. So U and V, this is going to look the exact same as it did before. So we're calling when components with speed and direction. And then we verify. True U is an array of 0 minus 7.0710, 0 and 0. True V is an array of minus 10 minus 7.0710 minus 10 and 0. So those are my expected U and V's for each of those inputs. And now we need to do an assert. Again, NumPy comes to the rescue with some helpers from their numpy.testing module. So we're going to use assert array almost equal. Does exactly what it says. We're going to assert that these two arrays are the same thing, two within a specified floating point precision. So U, true U, and let's go to 3 places after the decimal. Assert array almost equal V, true V, to 3 places after the decimal. Our last step of our 4-phase test pattern is cleanup, and there's none. Oh, sorry about that. Scroll back up. There we go. I was chatting with one of you over the break about, I like to have, I hate typing the same thing over and over again, so I have a little template as a text expander snippet that has def test underscore parens colon and then these comments for setup, exercise, verify, and cleanup already made for me. So I force myself with this template to, okay, I'm going to go through this 4-step pattern every time. So we just need to do one more thing, which is up at the top of this file. We have not yet imported assert array almost equal. So I'm going to run this, and then I'll go back to the code so you can see it if you need to finish it. Okay, we have not imported NumPy in our testing. So import NumPy as MP. Okay, there we go. So now we have 9 tests that are passing. We could delete those 4 that we've already written because those test cases are all encompassed in this one test with arrays. Scroll back down to it there. So again, this does keep you from having to write 4 tests. It is a little bit harder to figure out what failed when something fails. You have to look at the difference on these 4 elements on 2 arrays and say, okay, the 3rd index is what's going wrong. What could be causing that? So doing something like parameterization would be a better solution, but this is certainly better than nothing. It's the same with testing. You might say, well, I already have this large pile of code, and you're talking a lot about testing new things. To go back and say, I'm going to test all of this code at once, I'm going to spend 2 months and I'm going to write a giant test suite, would be crazy making. So the best thing is when you touch code in something that's existing, write tests for it then, because the things that you're touching are probably the hotspots for bugs anyway. So while you're catching up on that, just a few quick words on, there's a page that says testing philosophy, and there's a lot of things there and links that you can go and read when you're having trouble sleeping. But I wanted to go over a few of the ideas from that page. So one thing is, I mentioned that tests are a form of documentation, and they also are a form of a specification, especially if you're writing your test first. If you say, I can't write the test before I write my functions because I don't know what my functions are going to do yet, you should seriously question why you're writing that function in the first place. If you don't know what it's going to do, you shouldn't be writing code. You should be planning out what your code is going to be doing. I think testing really helps enforce good styling for the libraries or the code that you're writing as well. So you think about, how can I chunk this up into these little modular pieces that I can easily test, which is what you should be doing anyway. Never, ever, ever put something in your code that says, if we're running the test suite, do this. If we're not running the test suite, do something else. Because that completely defeats the point. And you will run onto that in a few places. So you don't want to do that, and we'll show you some ways to catch things like that with coverage checks later on. So the goal really is to reduce risk and do no harm. So your code shouldn't be more complicated because you're testing it. A lot of times people will say, well, I wrote more test code than I wrote production code, and that's great because that means the production code that you did write is probably relatively bulletproof, relatively being the keyword there. So also when you're writing tests, you might be tempted to try to access something that, I guess in C or C++ we call it private or protected, but in Python, you shouldn't be messing around with changing underscores, and you should use the front door is the testing method. You want to go in the way the user is going to go in to exercise the function that you're testing. You don't want to do a lot of nasty things to try to set up some sort of test scenario. Also, you've got to be careful when you're trying to talk to remote services, like getting data from the web, which we'll go over some ways to mitigate that kind of risk later. Ryan, can you think of anything that you want to add to the philosophy discussion there?
Where would you suggest to keep import statements? Like you may have some tests where you have namespace issues. You're importing certain modules.
So I generally would put all my imports at the top of the test_.py file, but you can put them in a given test if you need that because you're having a namespace issue. Yeah.
You can also do like import X as something
Right.
else if you do have namespace issues and avoid them that way, right? Yeah.
So just like your code can have code smell, your tests can also develop test smell over time. And so you're copying and pasting blocks of code like we did with those 4 tests for wind. That should be making you wonder, is there a better way to do this? The answer is probably yes. So you go to the pytest documentation, and later that afternoon you figure out a better way to do it. So keep in mind that you have to maintain tests as well as maintain your code. So write tests that are small, easy to maintain, well documented, just like your code. You shouldn't dread opening up your test file. Okay, so I won't go on too much more about philosophizing on tests, but if you want to hear things, as you can tell, I have no strong opinions on anything. I'm happy to discuss your specific case with you. Okay, so mocking. Someone asked, are we going to get to mocking? And the answer is yes. So I'm going to modify our URL builder function because I have found a more convenient way that I want this to work. So let's go modify it, and then we're going to see some interesting problems that poses when we go to test it. So in mediogram.py, find build ASOS request URL. And what I want to do, and remember I told you that it only updates roughly monthly in this database, but I want to say if I don't give you a start date, then the start date is going to be a day back in history, and the end date is going to be right now. So probably the way that I would implement this is make these keyword arguments with defaults. So I would say start date equals none, end date equals none. Don't forget to modify your doc string. So it defaults to 24 hours ago. Default to today. And then we got to put a little bit of logic in our function here. So if inDate is none, inDate equals current UTC time. So this is another function in Mediogram that gets the current UTC time. And you might say, well, why would you have a function for that instead of calling datetime.utc now? That will become clear in just a few minutes. Likewise, if start date is none, start date equals inDate minus datetime dot time delta, hours equal 24. So it says, if the user doesn't give us an end date, we're going to set it to the current UTC time. If the user doesn't give us a start date, we're going to set it to whatever the end date is, minus 24 hours. The user could give us an end date, but no start date. This will still work out fine. That's why we did it in this order here. So that's great. It's going to work beautifully. What problems are we going to encounter when we try to test it, though? So think about it. I'm going to write a test that says, does it behave well with the defaults? So if I call build ASOS request URL with FSD as the station and nothing else.
Time changes when you run it.
Yeah, the time changes. So every time you're on your test suite, you have to go in the test and say, okay, is it today? Is it today? And that's terrible. I suppose one could do something really bad like reset your system clock or terrible things, but that sounds horrible. So this is where something called a mock is going to come in. So we are going to take this current UTC time function and mock it so that when the test suite runs, it gets replaced with something that has a fixed date time as the return. So to do that, go into your test-mediogram.py under the conveniently labeled instructor-led mock example part. And we are going to write our mock. So def, I'm going to call it mocked current UTC time. Leave myself some breadcrumbs as to why on earth I did this. So I'm going to mock our UTC time function for testing with defaults. And then I'm just going to return a fixed date time. So 2018 3/26 at 12Z. Why not? So now we need a way to say, when we're testing, use this function. Don't modify the production code. Remember, that would be very bad if we went to the production code and says, if we're running a test suite, use mocked current UTC time. If we're not running the test suite, use current UTC time. That seems bad. So go back up to the top of your test. I'll scroll down there in just a second in case you were still typing. From unit test dot mock import patch. So this is the line that we've added at the top of test-mediogram.py. So what this allows us to do is use a decorator named patch on top of our test function and say, if anything inside this test that's running calls a function named something, I want you to switch it out for this function named something else. So it allows us to switch that, but our production code never knows anything happened. As far as it's concerned, everything's normal. Okay, so scroll back down to where that mock is. Okay. So this is semi-production code, I would say, right? Our user is never going to use mocked current UTC time, but we're going to use it internally, and how do we know it works? We test it. We are going to test our test code. It sounds crazy, but if it was a more complicated mock than this, it's something that you would definitely want to do. So def test, this is just a normal test. Test that mock works. This is also a good way to say, do I know how to use the patch decorator? So this is going to be test if we really know how to use a mock. Do we have any setup? Nope. Exercise. We say result is mediogram dot current UTC time. So we're calling the thing from mediogram that we're going to be replacing with the mock. This is simulating a user or our code calling that function. And we verify it. So the truth is this hard-coded value up here. So 2018, 3, 26, 12. And then we assert that the result is equal to the truth. Ah, thank you. Running the test suite is also a great way to prove to myself that I should not have passed typing. Okay, and then clean up.
Do you have any standard on your expected versus computed values orders?
Not really, no. And I call them result in truth or desired a lot of the time. That's just a convention that I use. But no, there's no order dependence there. Okay, so if we run this right now, should it pass our question? Yeah, so let's run it right now, because if this passes, we have a serious problem, because current UTC time is telling me that it's March 26, 2018 at 12Z. And either somebody's got a DeLorean or I broke my code. Okay, so let's run the test suite. All right, it failed because the current time doesn't equal that. Excellent. So now we need to actually use the patch decorator. So at patch. Then the first thing we have is what we want to replace, what we want to substitute. So mediogram dot mediogram dot current UTC time. So that's the function that we want to replace. Notice it's a string. Yeah, thank you. No, mediofram. There we go. And then new is equal to whatever function we want to replace it with, which in our case is mocked current UTC time.
This function is taken from the suite scope. So if I do it for numpy as np, I should write np there or numpy. I mean, I guess I can try both. Just if you don't.
Off the top of my head, I'm not sure which way you would have to do it. Yeah. So the question was the namespacing of this. Would it be np dot, and I'm guessing it would be full numpy, but that's a good one to try. So now I run pytest, and I probably didn't save it. There we go. So now it passes. So we have successfully tricked mediogram into silently swapping out this one function for us. So now in the test mediogram file here, what I want you to do is add a test that tests the default behavior for the URL builder. So you're going to use patch, because we're going to accept the current time as the end time, and today -1. as the start time. So write a test for the URL builder that uses our mock. Sticky notes down, blue sticky note up when you're done, red sticky note when you need help. Okay, so I'm going to go ahead and go over how I would probably do this. In reality, I would write 3 tests here or use parameterization, which we'll get to. I would do one for all the defaults. I would do one for if the user specifies start but not end, and I would do one for if the user specifies end but not start. So you would need to write each of those combinations of tests here. Okay, so we are in the exercise. So I'm going to use, well, I'll put the patch on last. So test, build, ASOS, request, URL, defaults. So setup, don't have any this time. Exercise, so the URL is mediogram dot build ASOS request URL. And for fun, I'm going to switch it up to another station, MLI. I think that's Moline. And that's all we need because we're using the defaults for start and end. And then we verify. So our truth is empty string, assert URL is truth. Okay, now we need to do our patch here, use our mock. So the patch decorator. I didn't mention this, but this decorator modifies everything that happens inside this test function and only inside this test function. So after you leave this test function, current UTC time works just like it would from mediogram. So the patch only affects that function, but it affects everything that happens inside that function. Okay, so mediogram, we also had some questions on, so this is the package, this is the module, and then this is the function or method or class or whatever. New is mocked current UTC time. Also saw several folks, and I did this the first time I was playing with this, do that. That will not work. That calls the function, so it takes whatever that function returns and says that is the new thing. So we don't want that. We want to actually have the function. Likewise, if you put parentheses in this string here, you will get a very interesting error message that has 0 hints as to that is what's really wrong. So if you're having problems using patch, it's probably that you have parentheses somewhere you are not supposed to, or you're not going package module thing. Okay, so I'm going to run this. And of course it fails because my truth was an empty string. So I grab that URL and I go test it out. Does it work? Does it give me the dates I expect? There we go. So remember our date was March 26th at 12Z. So we should end there and start on March 25th at 12Z, 2018. So there's March 25th, 12Z. Scroll all the way down. March 26th at 12Z. So we got the data we expected. That URL is indeed valid. So we've got it copied. I will paste it in as truth. Now we run pytest and we get it passing. So questions on using mocks. Yes.
So this was dealing with time changing, whatever. What other times does mock maybe come up?
I'm trying to think of a good general case. I use it a lot for simulating hardware that's not there because I deal with a lot of hardware things. So I mock a hardware device that's not connected to my test machine. But databases, that's another good one, yeah. There's another question over here too. Yeah.
So this isn't specific to mock, but the string that we're creating and passing around for the URL, I feel like it's a little unwieldy as we keep copying it in the tests. And so I keep going in and checking for like making sure I'm looking at the correct hour1 equals and like going in there. But to put variables for each of those seems like a lot too. And
Right.
So
Yeah.
I'm curious like the trade-off there and how you feel about copying this whole string and editing like the little part versus like, I don't know, making something ridiculous like a builder for that just for testing, you know? Like,
I mean, if you're going to test your builder, then I would do that, but then you're going to still be making the ridiculous strings anyway to test your builder. So I would probably just put them in, unless if you expect this to be a volatile web service. So if this REST API was going to change in a few months, maybe a builder would be nice because then you don't have to go through and manually redo this. This one is very likely going to be exactly like this, or at least backwards compatible until sometime slightly after the end of the sun. Yeah. Yeah.
So you're putting in something that is static and is not going to change things. What if I have a dev or test environment that is not production but is still kind of fits in the middle? Is there a way to make mock like take it or somehow indicate that it's not perfectly safe or it's doing actions? Not just mocking. Do you understand what I'm saying?
Off the top of my head, nothing comes to mind on a good way to do that, but I'll think on that some while Ryan's talking to you all, unless he's got something that comes right up in his mind.
Not right away.
Yeah. I'd really like to hear more about that, so find me after this. Because weird test cases are always fun ones. Yeah.
Are you going to talk about how to mock hardware?
No, unfortunately not. Again, if you want to talk about mocking hardware, I'm happy to, though.
What if I wanted to permanently mock that and not use it anywhere?
So you could mock it for the entire test file.
So that's a decorator which tracks a function.
Yeah, and there's from unittest.mock, you do something else. I don't remember what. I would probably never do that, though, because then you might accidentally be using a mock and don't remember that you're using the mock for the whole test file, unless Ryan knows how to do it off the top of his head.
So this came up before with someone else, and so the benefit with having the patch everywhere is that you know every function that uses it if you didn't want it globally for the file. If you're just doing it for the file, honestly, the best part about patch is that it returns you back to the normal state. If you're just running this for the entire file, you don't care about returning. So literally you could do mediogram dot, so you can see what I'm talking about. So you could do mediogram.current UTC time equals mocked current UTC time. And that accomplishes the same thing without using the decorator. Really, the benefit of patch is that it keeps track, and regardless of what errors propagate out, returns you back to the beginning state. So if you don't care about that, if you're doing it for the whole file, then there's no point using patch. Yeah, this is structured monkey patching.
And you maybe current UTC time right now doesn't have a test, but maybe I would write a test for current UTC time that really is going to use the current time. So patching it for the whole, or doing it for the whole file would not be a good idea. Yeah. Other questions? Okay. So that's it for mocking. We're not going to talk too much about test helpers in the interest of getting to some things like coverage, image testing, fixtures, parameterization, before we have to let you go in about an hour. So, Ryan?
And just wanted to come back to the question about the hardware. In general, if I'm thinking of testing hardware, you'd have a class that represents the hardware device you're talking to. That's where something like magic mock or something, these other things that exist within unittest.mock, where you can mock out an entire class and say, this func method should return this for my testing purposes. And checking that the function was called or these functions were called in this order, you can really get into the nitty gritty. So if you're thinking about that, magic mock is probably where I'd start looking for something like that. Okay, so Coverage. So we've written all these tests. One of the nice things to be able to do is figure out how well is my test suite exercising all of my code? How do I know what lines in my library are actually being executed and what places, essentially, how do I find where the bugs are lurking? Because my tests run and I know there's nothing there, but it's the parts that I'm not running is where my bugs are going to be found largely, especially all the name errors, the typos, things like that. And so coverage is a nice way to figure out how you're doing in terms of exercising your code. Fortunately, there's a nice coverage.py module in Python that exists to track coverage and figure out what lines of code are executed. And then there's an extension for pytest that runs this automatically for you so you don't have to worry about it. So we can start by running pytest-cov. And I will blow this up so we can see what we're talking about here. And so we can see, excuse me, when we do this, we have our init file for the package. Okay, there's nearly no statements in here, but it's being executed. We have 53 statements in meteogram.py that are being run, or that are in there, and 28 of them are missed. So we're only covering about 47% of meteogram.py. And then in test meteogram, there are 69 statements. None are missed. Coverage is 100%. It might seem funny to look at coverage of your test files, but that's actually really important. One of the frequent errors you might run into is, I'm going to add a new test. So I'm going to copy and paste an existing test and then modify it and have my new test. If you do that and you forget to change the name, you now have one function replacing the other one, and you have an entire test that's not running anymore. And so actually looking at your coverage of your test file is a great way to know, am I running all my tests? I've done this on a few projects where I've added these things, and lo and behold, I find tests that weren't actually being run. And then when I enable them, lo and behold, bugs emerge. Like, oh, that test was actually important and needed to be being run. So just something to keep an eye on. So when we run pytest coverage, we can also control the kind of report we get out. Here we got a kind of a summary. If we say pytest-cov report term missing, so that's terminal with missing lines. If I run that, where's my report? Oh, so I added the report, but I didn't tell it to run coverage. So let's try that again. Okay, so now we see we have the same coverage information, 47% coverage, and now we have a list of what lines of code are not being tested anymore, or not being tested at all. So we say line 39, 63, 86. So if I come back over to my editor, we can say, okay, where's 39? Oh, that's the test file. So over in meteogram.py, line 39. Okay, so there's one function that has no test covering it. Downside of using the mock. It's nice that we could handle running through and testing the defaults when we don't give it a date and time, and we're not beholden to what the current date and time is. But now, when we run our test suite, this current UTC time function is never exercised. Problematic because that's where that's where your bug's going to end up being. That's where, if I took out this, that would be a bug. That would never work in production, but my test suite's not going to cover it all until I actually run it live. You're not going to actually know that there's something wrong here. Let's see what else we have. Line 63. So line 63 is within this potential temperature calculation function. So that's just, we haven't written any tests for that. And so on. So let's take 10 minutes or so and run a coverage check on your library. Use that report to figure out what lines of code are not being tested right now. And add some tests to try and cover some lines. And see what you can come up with to maybe tackle this problem of, how do you write a test that checks whether current UTC time is working correctly? For potential temperature, I understand you all are not meteorologists, but helpfully the doc string down here says for inputs of 800 and 273 Kelvin, the output should be this. So it's nice having that in the docs and all, but why don't we have a test that actually verifies that the function behaves as expected? So let's take 10 minutes, try and up your coverage, and then we'll move on. I'll take some questions.
Scroll back and turn
Sure.
that last command.
Absolutely.
Modifier. And what's the command?
Here, let me. And I'll also say, if you're using PyTest for your own work and the coverage module, there are a lot of other options in terms of the coverage report, getting an HTML report and XML, things like that. So just for our own use here at the terminal, the term missing report is probably the easiest to get going with. So there's one other option here when we call pytest-cov, and I didn't need it here when I was running it, so I didn't show it to you all, but when you do -- we can say equals and give it the package we want to actually see coverage for. So at least one person, I suspect I'm probably the special one here, and all of you are seeing a bunch of output if you run this. You can restrict the coverage not to say coverage of NumPy, SciPy, everything that you're importing, but just our package by saying --cov equals meteogram. And then that should restrict your output, or restrict your coverage numbers to only the library you care about. Like, it's nice and all seeing what percentage of NumPy my tests cover, but I don't expect to have any kind of significant coverage of NumPy's functions in my test suite. All right, time's ticking away from us here, so let's move on. I will show you testing current UTC time. So that was one function that had no coverage. And this is, it's a way to test it. I don't want to say I'm proud of it, but it works. So test current UTC time. Set up none. Exercise. So result equals meteogram dot current UTC time. Verify. So one thing you could do, we could make what we call a smoke test. And essentially what that means is when we run the function, does smoke come out? Does it burn, crash and burn, or does it, in this case we can even assert, does it give me something? So we can even prove that it returns a value that's not none. That's one thing. It's not great, but at least would solve the thing, is there a lurking name error or some other error that's in there? Better than nothing, but we're also not doing anything to check the behavior of that function. This thing could go rmrf my home directory, you know, there's no check there. There's all sorts of things. So instead, the way I came up with for trying to test this is say, so truth is datetime.utc now. So we can do this and assert it, and everything's going to be happy, right? Ah, thank you. That's great. That will work every time. Testing can't solve everything. So, no, it does not work that way. Why? Because in the microsecond field of our date time, there's a difference of 2 microseconds. So the best way I could think of to try and solve this was you can call replace on a date time and say microsecond equals 0. Replace microsecond equals 0. And just obliterate the microseconds field on those date times. And if we run pytest, then it succeeds. Can anyone think of a problem with that approach?
Running a computer from 1986?
True, but not one I'm worried about. Yeah, so if you are unfortunate enough that if it rolls over the microseconds while you're running your test suite, this test will fail. So this could be one of those annoying things of 1 in 10,000 runs, probably even less often than that, you're going to have a random test failure. So it's not the greatest way to approach this. I can't come up with even a better way to test this.
What if you just take the difference in the 2 times and say? Okay.
That's probably, actually, that's even a better way to approach that. Do you have another one?
You can do the timestamp function on it, and then do the assert almost equal.
Also going, those are 2 really good ideas. So one is to calculate the difference in C, and the other one would be to, if you use timestamp from pandas.
No, you can just do dot timestamp.
Oh, dot time. Oh, okay. If you use dot timestamp, it would give you some floating point values that you could then use assert almost equal with. So those are better than the solution I had here. So I'll have to remember that for next time. I like that better. All right. So any questions about coverage before I move on?
Can you just quickly show the solution?
This? Yeah. I mean, solution in quotes here. Okay, so that's a real quick introduction to coverage, but it's a nice tool to have. And there are lots of web services, or a couple web services for open source projects, where you can upload these coverage reports, and you can have GitHub pull request check what the coverage is on the pull request and see if it went up, or if at least all of the lines in the pull request are covered, things like that. So there are automated services that help you analyze these coverage results. And I think there are many other options you can do here with pytest or coverage as well, to get HTML reports and annotated source and things like that. Okay. How many of you all have used matplotlib for plotting? Okay. How many of you would have liked to be able to check whether your plots are working or breaking? Okay, so that's one of the other advanced topics we're going to cover here in the next few minutes is image testing. So there is a plugin for pytest called pytest-mpl. And what that enables you to do is to write tests that generate matplotlib figures and have it do a pixel by pixel comparison of the 2 images and see, are your plots still producing the same results? You could think of, if you were just doing a plot, you could do a smoke test like I mentioned before, at least that your plot code is not producing an error. But using pytest-mpl, we can verify, has my plot changed between things? Have the bounds shifted? Are lines still there? Is part of the plot just missing now? Things like that. So if we want to make an image test, just like before, we're going to define a function. In this case, it's going to be a function that that generates a plot. And I guess I should show you over here. What we're testing here is in mediogram.py. Down at the bottom here, I'm sure you've scrolled past it many times, there's this plot mediogram function. It takes a data frame, a pandas data frame, runs a whole bunch of plot methods, and generates a plot of the data we've downloaded. So it's this big complicated thing, and we kind of just want to verify, is it working in generating my plot? So our setup here is going to be a bit more involved than we've had kind of before. We have a URL we're going to get. So we'll put a start date on March 26th, an end date. Okay, we've not encountered this function before, but there's a function in the library that will go download this data and give it to us as a data frame. So we say df equals mediogram download ASOS data, the URL. So that goes out to the web, downloads the data, and gives it back to us as a data frame. Okay, now let's exercise our plotting code. So we have fig and a couple other things that we're throwing away. It's kind of the convention with the underscore there. I'll show you what the function looks like in a second. So if we go back to mediogram, we see our plot function. Returns fig x1, x2, x2b. So it's actually mixing an underscore. So it returns a figure that we created with matplotlib, as well as a few other of the axes that it drew on to generate the plots. So it returned all that information. In my test, I really only care about the figure. So we'll just keep using underscores for the things we don't care about that are being returned. Okay, so we don't need a verify step here. That's one of the beauties of using pytest-mpl, is it will take care of the verification step for us. There's no cleanup, but the one step we do have to do is we need to return the figure that's created. That's how the hooks will work, is we return figure when we're done in this test function. And the only last step we're missing is we have a decorator here, pytest.mark mpl image compare. That's how we tell it that we want to do an image comparison test here. So it marks the test, and then it's looking for that return value of the figure to then do its image comparison. One option you will most likely always want to be using when you're using this, if you're using this, remove text equals true. One of the parts of doing these image-based comparisons is it can be very finicky, especially with text. You can get little pixel differences that aren't significant to you, but the computer is going to pick these out really well. And so one way to reduce these small differences is to not put any, remove as much text as possible. Tick labels, trying to think what else it removes besides tick titles. Those are the things that change a lot in like versions of certain libraries on your system. And so to try and keep the test from falsely failing, we say remove the text. One other thing we'll need then is to go up to the top and import pytest. So, proto test, decorated it, put our import. So now let's run it. And actually what we want is, we'll say pytest. So this is an option we haven't encountered so far. You can pass -k and say test plotting mediogram defaults. K is kind of a substring. It's going to look for all tests that contain that test plotting mediogram defaults and run those. So it's a way to kind of not run the entire suite, just the one test function we want. Then on this run, we're going to say --mpl -generate -path equals test. Where am I? I think mediogram test baseline. It depends what directory you're in right now, but we want to have. We're telling it where to put the image. It's going to generate an image. Instead of run the test, it's going to take the image that's generated when it runs our test function and save it to a file. And so I'm telling it to save that file in the directory mediogram tests baseline. If you're running it somewhere else, maybe test/baseline, maybe just baseline, depending where you're running pytest. But this is the default location it'll then look when you run the test later. So we're trying to put the image someplace it knows to look so then it can do the comparison when we run the test suite at a later time. So if I run that, you get this, with new pytest, you get this warning because pytest-mpl hasn't registered its mark there, but we can ignore that. It still works. We see it collected 13 tests. It deselected 12 of them because of the -k, so we only picked out one test. It gives us a -s because it skipped the test. It didn't actually run the test per se to check. It just generated our image. And if I look in Mediogram test baseline, we have this test plotting mediogram defaults.ping. So it used the name of our test function as the name of the image. I'm going to use open on my Mac because that'll open up the image. I have no idea how to do this on Windows. What we want to do is open the image file that was created and make sure that it actually is what we expect. I mean, if it was a blank image, we wouldn't want that to be our baseline image. We'd need to go debug the code. So that's what it spit out. That looks reasonable for what I'm expecting. The red would be air temperature, the green would be moisture content, and some wind information. Looks reasonable to my eyes, so I'm happy with this. Most importantly, it just wasn't blank and it's not complete noise. Those are the two things I'd care about.
Should the text be there?
Those texts, remove text doesn't remove all the text, unfortunately.
Okay.
Especially things we manually add with like X label and Y label. So if you don't want those, we should probably just, you could manually take them off. And there are other ways we can control the tolerance too, but I'll get to those in a second. But that looks reasonable. So now, baseline's good. So now if we run pytest-mpl, now it'll run the test suite as normal, but enable pytest-mpl, which means it'll do image checks. So if we don't put on the --mpl, it'll run your image test kind of a smoke test. It'll make sure there are no errors, but it won't actually do the image check. You have to opt in largely because the image testing can be very slow. If you think about opening, you know, if you have a lot of these things, opening all these ping files, doing pixel by pixel comparisons can be kind of a slow thing. So if I run that, okay, it ran and everything looks good. All right, in the interest of time, I want to get to fixtures. So I want to skip the exercise on this and move on to talking about fixtures in PyTest. But I'm happy to answer more questions about the image test. Yeah?
I'm missing the magic here. So in the first run, we generated the image.
Mm-hmm.
How PyTest know where to find the comparative image inside of the code?
So when we did the first one, nope, there we go. So when I first ran it, I said mpl generate path. So then at that point, it ran the test file, took the plot that was generated, and saved it to an image file in this directory.
Which is a custom directory.
Yeah. It knows to look in, its default directory is going to look in under the test directory in a subdirectory called baseline. That's the default for pytest-mpl. Yeah.
Test baseline is magic path and mpl.
Which,
Look for this kind of, okay.
and you can configure that in, I think, pytest.ini or some other places. You can set that something else if you needed to. But yeah, if you just use baseline, it just magically works.
Okay, that was my...
Gotcha. All right. So, fixtures are another, they're kind of related to mocks in some ways. It's another way that we can help try and get some things set up in testing, and we'll use it in this case to try and avoid downloading some data. So if we notice, if we come over here to our test file in test mediogram, I go down that image plot, for instance, right here. So that's calling download ASOS data. That's going out to a web server every time we run our test suite, downloading some data and parsing it. Speaking from experience, things on the web go up and down more than you want, especially when it's in your operational production test suite. So, word of advice, avoid contacting external services as much as possible. So in this case, we want to try and find a way to avoid having to download the data but not also then everywhere have to read in and parse this file. And so we can use a fixture as a kind of way to pull out common setup code into a thing that we can just use in the test functions. So I'm going to put this up at the top. So I'm going to need the pathlib module. So we're going to import path, and we'll see why in just a second. And we're going to define this function, load example ASOS. And fixture to load example data. So instead of downloading, what I'm going to do is I'm going to go download a copy of that data and save it into a path in my repository. I'm going to use the pathlib to kind of easily figure out where that's going to be. So we can say path and then pass it _file. If you've not seen this in Python before, there's a special attribute _file that gives you the path of the current file you're in. In this case, our test-mediogram.py, the full path to that on disk. And we can say resolve that. I want to go get the parent directory. So now I've got the directory that test-mediogram is in, the test directory. We can go up 2 levels from that. And now we're in the base of the repository, and we'll add static data here. Our data file is in our example data path with amw example data.csv. So all of that's just a bunch of path manipulation. And if you've not used the pathlib module before in Python, essentially it does this nice thing where it overloads the division operator and instead does that for path joining. So no more os.path.join in a big list. We can express things this way. And the last thing we're going to do in this function is we're going to return mediogram.download ASOS data path. It's kind of a misnomer on the download part because this can also just open a local path. So what we've done is we've resolved the path to our static data directory, given it a local CSV file, and handed it to that function. We tell pytest we want this to be a fixture with this decorator at pytest.fixture. This will make sense in a minute why we've got all this. Well, what we've done here is we've defined a function that returns some data and said at pytest fixture. Now what we do is we come down here to our plotting function, our plotting test, where we did this, and we say, here it is, we add load example ASOS as a parameter to this test. Because we declared a fixture, what pytest will do is it will take care of run that function, get the results, and automatically pass it in as an argument to our function here. And then we can get rid of this part of the setup. And we can say our data is just load example ASOS. Or if we really wanted to get rid of it, we could just take this, throw it in here, and then we have no setup. So what the fixture allows us to do is take all this common setup code, put it somewhere else that is automatically wired up for our tests. This could be setting up a mocked up database. This could be setting up connections to maybe a test database. it could be any number of things. Now, if I run this right now, what we're going to notice is we get a file not found error because we haven't actually downloaded our data. So, on the on that site, there's a link to the our text data. If we go into fixtures, there's a link here. The data are here. This link here. That opens up one of those URLs that has a whole bunch of data. So I run that. I'm going to save this to a file. I put that in a folder called static data and save it as, I called it AMW example data.csv. No, do not put .text on it. Okay. So now, if I run pytest, what did I do wrong? Thank you. So, correct my typo over here in my fixture. So let's try it now. Okay, there we go. So now we have this fixture that we can reuse in all of our tests that we're downloading data, and instead just have our example data sitting there ready to go. And so we could reuse this across all those functions, and then any changes we need to make here in terms of how it loads the data, what processes, what functions, are all encapsulated in the single function that we don't even have to automatically call. Don't have to worry about calling conventions, parameters. We just need to set it as the name of an argument to our test function. And so that's what fixtures are really good for. So, any questions about fixtures? I know it was a very quick run through of them. Yeah?
The static data is data that you've already downloaded and subsetted and...
So the static data directory, we only have the one file here, but in general, I mean, you can call it whatever you want. That's just kind of the convention I've used in the past on some other projects, is just having this directory of downloaded data sitting there. Yeah.
Yeah, that download function is just reading it.
Yeah, it's the function says download, but really what it's doing is, part of it is the fact that pandas can read URLs, so that's where it kind of comes from.
Subset it or you put in another function to like if you wanted to...
It's all the data that's returned. Yeah, if you were working, if the URL was returning a bunch of data, then yes, you'd very much want to try and probably trim that down to whatever is needed to exercise a particular use case. Sometimes you might need a lot of data. You could have a test that maybe validates performance, or that, you know, it doesn't blow up. Maybe you've had memory issues with too big a data set. You want a test that actually makes sure that this function doesn't crash when you get too much data. So sometimes you need a lot of data. Other times you might end up being very sad that you wrote a test that reads in 1 gigabyte of data and takes a bunch of time, makes your test suite slow, when all you really need to do is check 2 lines. So there's, you know, you got to look at what are you trying to do, and do as much as you need to accomplish that, and no more.
So my impression is like the importance of a fixture is you only really need to run it once for multiple tests.
Run
So it gets run multiple times if you have multiple tests?
I believe that's the case. Yes, it does. I think it's a clean execution every time you do it. So on some things, that's really important. I think there are ways to wire up the fixtures so that they do only run once.
Okay, so if you do have like a very long, slow setup process.
Yeah, you can, if it's slow and intensive, you can do things to make that so it only runs once.
And you control the scope of the fixture?
That's my recollection. Just getting into the parts of the PyTest where I have to go look at the documentation every time I want to use it. But yes, there are ways to control scope. There's ways to control. You can set fixtures so you don't have to pass as a function parameter. It's just what they call auto-wired. And so you can have ones like that as well. I usually go with explicit better than implicit unless I'm going to be putting it at every function in the file, then I probably want it to be wired up for the entire module. Of the advantage of the decorator? Okay, so yes, I mean we did a couple different things here. So the one thing was just making it static and local, and that eliminates the download, which is good to do in general. The reason we use the fixture here is so that we can kind of refactor out this common setup code into, we could use it in multiple places and have it, and you know, if we didn't have this as a fixture, we'd have to have all this path manipulation and code to do the download and the parsing in multiple places within all our functions. So if I decide that maybe we refactor this function and there are parameters that say columns equals whatever, and maybe there are additional API parameters. I've got a test suite that calls this, that uses the same data 20 times. If we don't use a fixture like this, we've got to update now 20 calling sites to go change how my test data is loaded. Whereas by using the fixture, I've got one place where I can change how this input data comes in, and I don't have to update all those 20 calling sites. It's a modularization type feature.
So why not just write a function in your test script that does all that stuff, and then just call that function in each of your test functions? Or am I missing something?
No, that works perfectly well. I mean, I think there are cases where if you're using more of the advanced features of fixtures in terms of the auto setting it up. I have a fixture in some other test cases that are setting matplotlib backends or things like that. So there's more of the advanced features of fixtures we haven't really used here. So I think that's probably where the disconnect is versus using a simple function. I think it's maybe like a few characters shorter here by putting this in the function argument than calling it. But yeah, that's fair. You can also do things in PyTest like parameterize the fixtures as well and really start.
The auto wiring is really convenient, and it's a nice flag to use. You're going through, okay, this is a function or a test that's using my fixture. I don't have to go and start reading inside that test code.
You could also conceivably do things where the fixture does loading of different types of data, and you're just trying to exercise, does this pass, does the database succeed or whatnot, and you can do it across multiple database instances or multiple methods of reading the same data, and just kind of have it swap out the fixtures. But that's getting into a lot more deep test stuff.
Could you just mock this function instead of fixture?
Could you mock instead of fixture?
When retrieving?
Yes, you could. You could absolutely. That's now it's just software engineering solutions and trade-offs. So, I mean, a lot of this comes down to, especially coming out with my scientist hat on, whatever way you're actually willing to write the test is the way you should do it. Like whatever gets you writing more tests and getting more coverage and actually testing your code is more important than the nitty-gritty of, well, is the fixture the right solution here or is a mock the right solution? I mean, if you're already thinking about test and writing the test, that's 98% of the battle right there.
A question about the image
So, yes. Since I'm just probably in question and answer session at this point, I will show, no, because I think we're just about up to time here. So, the one thing I didn't show you all here is when we do image comparison, we can pass it a, is it tolerance? Yeah, it's tolerance, or if I can spell tolerance. Tolerance equals, and then it's a RMS value. And honestly, the best way to figure out what the value should be here is to see it fail, compare them, and it'll spit out the value of, well, these failed with a the RMS value of 0.2 or something. And you look at them and say, this should have passed, and you put a value of 0.2, maybe 0.3. It's not something you can generally specify without seeing it fail. So I usually leave it at 0, run my test suite, over time I start seeing some failures and then adjust that value as necessary. It's not the cleanest way, but it beats not testing your plotting code at all. Mm-hmm. Any other last questions?
Just a last question, is this plotting thing only for matplotlib, or could it be theoretically any picture PHP?
This particular one, the pytest-mpl, is only going to work for matplotlib figures.
While we're answering the last few questions, if you would give us a little bit of feedback here. So on your green sticky note, something that was good or that you found useful about this class this morning, and on your red sticky note, a way that we can do better, a way that we can make this class more useful to you. And be brutal, it's okay.
Other things. I think just one closing thought on this is, with the tests, whatever you do that proves to yourself, hey, this code's working, whatever I just created is actually sane and is doing what, I convinced myself this code is a success, that's what you should be testing. If nothing else, just whatever you did to prove to yourself this is working, take a few minutes, make a test function, and code that for the computer to keep checking it for you. That's the best tests, because that way you get for free whatever you already put together, and then you know that doesn't change. And that gets a great way to get started with the testing. You don't have to go in here and write 20 unit tests that test every corner case unless that's what you need to be doing to prove to yourself it's working. But at least test whatever it is you initially do to prove to yourself. Any other last questions?
So I work in a data science environment, and so we have to deal with pretty hefty SQL queries. Any advice on testing big databases, unless it's just creating your own integration database tests?
There are tools to mock SQL databases.
There are tools to mock them up. I think it depends on what you're trying to test. If it, you said big databases. If the big is part of what's causing the problem, you probably have to have a standalone instance to do the testing against, just because this sounds like if the volume of data is important, you're not going to want to mock that. You're going to have a standalone test database. Yeah, I think that you can go either way there, depending on the exact nature of the problem. Sometimes mocking might be good. Sometimes just a test database. All right.
And
well,
Ryan's going to be here all week. I have to head out after tomorrow, but I'll have some cards out down here, and I think Ryan will too.
Yep.
So you can pick up a card. Feel free to get a hold of us at any time if you've got any questions, and leave your stickies down here. But thanks for coming.
Yeah, you all have been awesome. Look at Scipy.